Welcome to section 6.4. Here we're going to remind ourselves how to graph sine and cosine. So the first three sections of this chapter are really devoted to basic trig, just what are the trig values and things. So you can definitely review that on your own as you need. But you'll find out if you really need to as you work through these sections that are in the latter part of 6 and the beginning part of 7. And so let's take a look at just some basic stuff. I think we all walk in here knowing what sine and cosine look like, and that's what they assume as well. And so as you get into the homework, they'll just get into some graphs that are being adjusted right away. So how do we adjust graphs? Well, you remember from your trigonometry class that you adjust them by adjusting their amplitude or their period. They're not doing any phase shifting here, which is good. So everything's just an adjustment in amplitude and period. And so let's take a look at the first question. Y is equal to 4 sine x. So we know what that 4 does, right? That 4 is going to take all of our sine x values and multiply them by 4. And so it's going to increase the amplitude. And so what's our sine x graph look like? And you have to choose the right graph or graph it yourself. If you remember, sine of 0 is 0. And so it goes through there and it peaks and comes down, comes back up at the trough and back here, goes down and comes back up. Now where are these down points? This is 0, this is pi over 2, this is pi, this is 3 pi over 2, this is 2 pi, right? It does a complete cycle between 0 and 2 pi, and that's why we say its period is 2 pi. Now, I know this doesn't look like the best graph in the world, and neither does yours. You'll be using a graphing system when you have to graph them, and so it will produce the sine wave for you. And so we know that this has a low value though of -4 and 4. That's the adjustment that was made. And so we have this sine x graph that goes from -4 to 4. And they're going to ask some questions like, hey, what's the amplitude? And the amplitude is how high it is off of the x-axis, and so that's 4, right? And then what's the period? And the period is, well, the period is what it always was, 2 pi. We didn't adjust that. So they'll ask that in some of the questions. They'll also ask for when the function's increasing. Well, it's increasing on the interval from 0 to pi over 2. It's also increasing on the interval. If I just focus from 0, I don't know where they're going to have you focus, but if I just focus from 0 to 2 pi, it's also increasing from 3 pi over 2 all the way up to 2 pi. If I stop there. Okay. If they made it longer, like if they had another one, it would be increasing from -pi over 2 to pi over 2. But I just limited myself there. I'm not quite sure what they did. Let's suppose they just said, they increased that range a little bit. They didn't stop it at 0. Then we'd have to say, hey, I'm increasing from -pi over 2 all the way up to pi over 2. I'm decreasing. If I look at this interval, I'm decreasing from pi over 2 all the way to 3 pi over 2. It's dropping that entire way. And so they're going to throw in the increasing, decreasing that we learned in this class, but everything's visual. So we'll just focus on the amplitude and period and answer those questions as they need to. Don't panic about what they're going to do from time to time. So here's the second question. They know that you're a good math student, right? Y is equal to 8/3 is what I wrote down that I saw in the problem. Cosine of -2 pi over 3x. A little bit complicated, right? But this was there right in the beginning. Our amplitude is being adjusted to be 8/3. Now, what about my period? The original period of cosine is 2 pi. And if you remember, you divide by don't worry about the negative part of it. The negative is just going to have us flip it around. The negative shifts it around. In fact, that actually may be a mistype on my part. Let me take that out of there. It doesn't look like that's there. So let's just focus on 2 pi over 3x. If you remember from your previous class, you get your period by taking the original period and dividing by any number that's with the x. So what's that? That's 2 pi over 1 times 3 over 2 pi. And so I get a period of 3. So you know what we do. We say, okay, we're not shifting this thing at all. It's our regular cosine graph, so it peaks right at 0. And it falls down, goes low, and comes back up. There's a full period of it. Let's just graph one period. They may ask you to graph more. But what's a period for us? Well, a period is of length 3. Okay, so right in the middle is 1.5 or 3 halves, however you want to write that. Right? But no pi's or anything. Our period is 3. What's my high value? 8/3. My low value? -8/3. Right? What's my amplitude? 8/3. What's my period? 3. And we're just moving forward. Right? Just a reminder of things that we did before. Third graph that I saw, a little bit nicer. Y is equal to 5 sine 1/4 x. And so, I saw these in succession, so they don't go from good to bad, everything's relative. And so what do we have here? Same problem as before. We have a amplitude adjustment to 5, and we have a period adjustment. And the period adjustment is the period of sine, which is 2 pi, which we know coming into the class. We can divide by 1/4. We know what that is. That's 8 pi. So what are we going to do? We're not going to stress. We're going to draw our regular sine, goes through 0, peaks, drops, comes back up, peaks, right? So this is 0. Now it did its whole period right up to this point right here. So this is 8 pi. This is 4 pi. This is 2 pi. This is 6 pi, obviously, going through there. There would be these natural spaces going in. Now, what's my height? My height is 5. And what's my depth? -5. My amplitude is 5. My period is 8 pi. We can answer all the questions that they need us to. Now, I mentioned there would be no phase shifting, and they're only focused on sine and cosine here, just wanting to remind us of the principles. What you'll find is visual interpretations of things really do help. So, as a next problem, a fourth problem, they do have this. Y is equal to 2 cosine x plus 3. So remember what the plus 3 does. The plus 3 moves us up 3 units. So I would totally recommend doing your homework in pencil, right? And again, it's always a recommendation. I would graph the cosine graph. So what I have here is 0. So for a momentary purpose, or for a moment, I'm going to ignore the 3, right? I'm going to box that, but I'm not going to look at it. I'm just going to look at the 2 cosine x. Remember, cosine starts up at a height of 1, except now it's going to be 2. So I'm going to go up at 2. Why is it 2? Because of the number out in front. It drops, and it's going to go to -2, goes down, and comes back up. Again, I could draw a second period if I needed to. What's the period? It goes to 2 pi. And we have our pi right here in the middle, and it's 0 at pi over 2 and 3 pi over 2, right? Just like we know. Okay, awesome. Now the one thing I haven't taken into account for them is the plus 3. Now the plus 3 is going to move this up 3 units. And so my height, remember cosine of 0 is 1 times 2 is 2. So it's really supposed to be up at a height of 5, but right now I have it as 2. So what do I recommend doing? Taking this x-axis and moving it down 3 units. 1, 2, 3. So this is my new 0. So this is 0. What am I going to do with these other things? Well, I've done them in pencil. So I'm just going to come in and erase them. This is the graph. How high is it? This was my 0. Oh, shoot, I still have my eraser, so I think I can fix that really quick. Remember, I'm missing a line because that was my 0 line right there. So I've taken this graph and I've moved it 3 up. How did I do that? I drew it at its regular height and then moved my x-axis down 3. I don't know how you did it in your previous classes. You're welcome to do it any way you want. This is just how I like to explain it. We definitely know that at this midline right here we have pi over 2. When it does its drop and dip, that's pi. When it comes back up to the midline, that's 3 pi over 2. And when it gets back up to its original height, that's 2 pi. And again, we could just keep this going out if they asked us to do more than 2 periods. That's how I would recommend doing things. Now, there is a fifth problem that I want to look at with you because it's at the end. And that fifth problem is the average rate of change. The average rate of change is just the slope. That's all an average rate of change is. And so they want us to find the average rate of change for f of x equals the sine of x over 2 when x travels from 0 to, let me actually write that out, x where x goes from 0 to 10 pi over 3. Okay, so what are they asking for? Well, they're trying to make a connection here that's at the very early part of calculus. Everything at the very, I shouldn't say everything, but a main part of the early part of calculus is getting rates of change. And so rate of change is doing nothing more, especially if it's an average rate of change, by saying where'd you start, where'd you end up, and what's the slope. You know how to find slope. From our pre-algebra days, it's the change in y over the change in x. No problem. So what's the change in y? Well, as I travel from 0 to 10 pi over 3, the farthest is 10 pi over 3, f of 0, and that's 10 pi over 3 minus 0. Perfect. That's all we have to do is solve this guy right here. So what do we need to know? We need to know what f of 10 pi over 3 is. That's easy. F of 10 pi over 3, remember what f of x is. That's sine of 10 pi over 3 divided by 2. Remember, our f of x was sine of x over 2. Sorry, I had to lose that. You know what this is. This is the sine of, take it in stages, 10 pi over 6 maybe is how you see that, which is the sine of 5 pi over 3. Now, this is what 6.1 to 6.3 has in it. You should know the sine of 5 pi over 3. If you're having to use a calculator or having to use a table to look it up, please note that you may not pass your calculus class. Calculus requires that you have these things memorized. And so when we say sine of 5 pi over 3, if you don't immediately think of the square root of 3 over 2, we're going to have a little bit of a problem. Now, I got to remember what quadrant I'm in. I'm in the fourth quadrant. All students take calculus. Uh-oh, it's going to be negative in that quadrant. So I get a negative 3 pi over 2. Let me separate that equal sign so that the negative and the equal don't bleed out. But we hope that going through a formal trig class, which is a prerequisite to this class, you would know those really, really quick. It is way worth your time to to memorize these values. Now, what's f of 0? F of 0 would be sine of 0, which we know is just 0, right? We've been using that earlier. That's all over 10 pi over 3. So now we have negative 3 over 2 divided by 10 pi over 3. No problem. Let me get rid of this stuff here. And then we'll just work down. And so I wanted to do this problem because it seems like, well, it's definitely like off on its own. It's not graphing, but they just wanted you to throw in this average rate of change. It's a good review of all your trig stuff. You might not have sine, you might have cosine. This is negative 3 over 2 times 3 over 10 pi, right, coming through. And so, oh, I apologize. This should have a square root on it. I don't know why I didn't have that on there, square root on that guy. So what do we got? We got negative 3 root 3 all over 20 pi. Done. That's the average rate of change. Nothing more than finding the slope. Slope was nothing more than plugging numbers in to figure out the y values. So completely doable. But this is the 6.4 section. Most of it is graphing, but you do have this average rate of change that slipped in there. All right, enjoy.